Hello everyone, I'm João from That's Brilliant, and in this video we're going to continue proving the derivatives of the trigonometric functions. So we have already proved the derivative of sine and cosine, and I'm going to include the link of those videos in the description below. In this video we're going to prove the derivative of tangent of x, and this proof and the next proofs, because we're going to have videos proving the derivatives of all the 6 trigonometric functions, but all the proofs are very similar, and we have already seen two of those proofs. So everything is going to be very similar to the previous videos. So I'm going to pass a little quicker over things, but if you have any questions, don't hesitate to comment them below, and I would recommend watching the previous videos. But as I said, I don't want to be too repetitive, so I'm going to be a little bit quicker with this proof. But again, do not hesitate to ask any questions. So let's start with the proof. We're going to start off in the same way. We're going to start with the limit definition of a derivative. So if we have a function f of x, the derivative of this function, which is f prime of x, is equal to the limit when h approaches 0 of f of x plus h minus f of x, and all of this divided by h. And in this case, in this video, f of x is the tangent of x, because the tangent of x is the function whose derivative we are trying to prove. So f of x is the tangent of x. And then we're going to apply this here. So f prime of x, the derivative of the tangent of x, is equal to the limit when h approaches 0 of the tangent of x plus h minus the tangent of x, all of this divided by h. And now we're going to remember a property of trigonometry which says that the tangent of any angle, let's say theta, the tangent of any angle is the sine of such angle divided by the cosine of such angle. So for any angle, the tangent is the sine divided by the cosine. And we're going to apply this here. So the tangent of x plus h is the sine of x plus h divided by the cosine of x plus h. So this is going to be equal to the limit when h approaches 0 of tangent of x plus h is the sine of x plus h divided by the cosine of x plus h minus the sine of x divided by the cosine of x. And all of this is divided by the h. So now we're going to do the least common factor for this expression over the h. So this is going to be equal to the limit when h approaches 0. And then just forget about this h for a moment. We're going to do the least common factor for this expression here. So the least common factor between cosine of x plus h and cosine of x is the cosine of x plus h times the cosine of x. They don't simplify, they just get multiplied together. So as I said, just forget about this h for a moment. Let's just do the least common factor for this whole thing here. So this is going to be, as I said, the least common factor between cosine of x plus h and cosine of x is the cosine of x plus h times the cosine of x. And then when we divide this thing here by cosine of x plus h, we are left with cosine of x. And then we have sine of x plus h times cosine of x. So sine of x plus h times the cosine of x. So minus, and then this divided by cosine of x is the cosine of x plus h. So it's going to be sine of x times cosine of x plus h. Cosine of x plus h. And now we can remember about the h. This is the least common factor for the numerator of this whole fraction. We have this h here, and we can put this h in this denominator, if we did this fraction and then divided by h, it would be a division of fractions. The h would get in the place it is here. I'm just simplifying things. But if you want to do step by step, you're going to see this is exactly equals to this right here. So moving on with our proof, we have to remember about another property of trigonometry, which says that, let's use the red. So when you have the sine of a minus b, which is the sine of the difference between two angles, this is equal to the sine of a times the cosine of b minus the sine of b times the cosine of a. This is a property we study in trigonometry, and we're going to do the reverse way, the other way of the function. We have this here, and we're going to see that this is very similar to this. And we are going to get back to this first thing here. So let's just analyze the numerator of this fraction. Let's call x plus h of a. So x plus h is a. X is b. So b and x, and here a. X plus h is a. Notice that we have the very same thing as here. We have sine of a times cosine of b minus sine of b times cosine of a. So we can go from this to this. So that's what we're gonna do. This is equal to the limit when h approaches 0 of. We are getting from this to this. So this is going to be the sine of a minus b. A is x plus h. X plus h. And b is x. So minus x. So notice that we have simplified a lot. All of this just became this. And then we have divided by h times cosine of x plus h cosine of x. So again, we have just applied this property right here to this whole thing. We call x plus h of a and x of b. And then we can simplify things here. X cancels out with negative x. So what we can do is, we have a limit of two things being multiplied. This is equal to the limit of one thing times the limit of the other thing. Let's just see. Consider this one part, this sine over h of one part, and the other part of another thing. We have one part times the other, which is just sine of h over h times 1 over cosine of x plus h times cosine of x. We have the limit of two things being multiplied together. This is equal to the limit of the first thing times the limit of the second thing. We have already used this property in the other videos, and this is just a property of limits. So this is the limit when h approaches 0 of the sine of h over h times the limit when h approaches 0 of 1 over cosine of x plus h cosine of x. This limit here is a very famous limit. It's very important in calculus, and this limit is 1. This is a very famous limit, as I said. Maybe we will have in the future a video that's proving that this limit is equal to 1, but this is a very fundamental limit that we study in calculus. So as I said, this is 1. And what is this? Just analyze it. When h approaches 0, this whole function approaches cosine of x times cosine of x. This h becomes 0, approaches 0. So this is equal to 1 over cosine of x times cosine of x, which is cosine squared of x. And remember, 1 over cosine of x is equal to the secant of x. So this is the secant squared of x. So we have just proved the derivative ddx of the tangent of x is equal to the secant squared of x. And we have just proved the derivative of one more function, of one more trigonometric function. As I said, if you have any questions, please comment them below so I can answer them. Thank you very much for watching, and I will see you in the next video.